Example 2 is a bit tougher, but a common type of complex question. So we're asked to simplify this, and as you can see, simplifying that using traditional methods would be a real pain. So what I'm going to do is I'm going to take each of these parts, I'll give them a name, 1, 2, 3, and 4, and I'm going to quickly put them into polar form, and then the simplification from there will be really easy. So we'll start with 1, and in 1 hopefully you can see that r is equal to the square root of 1 squared plus 1 squared. There's a negative in there, but the negatives become positive, so that's nicely the square root of 2, and theta is equal to tan inverse. I've got to be careful here, so it's 1 over negative 1, and that will become, that'll come out of your calculator as negative pi on 4, or as an exact value, negative pi on 4. But this guy on an Argand diagram is actually negative 1 plus I, so it's up here. So we're dealing with a second quadrant, and negative pi on 4 is in the fourth quadrant. So actually I'm going to convert this to 3 pi on 4. For tan I can just add pi to move it around. So I get 3 pi on 4 as my theta value, and so overall negative 1 plus I is equal to root 2 cis 3 pi on 4. That's the first one. 2 is already done for us, so we get 2 cis pi on 3, so that's nice. I'll just quickly do the third and fourth, and you can just email me if you have any questions. Okay, so now that we've got those values, I can write them out in full form. Root 2 cis 3 pi on 4 all to the power of 7 times by 2 cis pi on 3, that's a 3 by the way, that's better, all cubed, oh, that should be all cubed, divided by, and we had that I one which is just cis pi on 2, but nothing happens to that, and then multiplied by, and I didn't write down the full version of this last one, but it's 2 cis negative pi on 6 to the power of 4. Now I'll do my DeMoivres theorem powers, so I get the square root of 2 to the power of 7 cis 21 pi on 4 times by 2 to the power of 3 cis 3 pi on 3 divided by cis pi on 2 times 2 to the power of 4 cis negative 4 pi on 6. Okay, and then I'm going to do some simplification now. Root 2 to the power of 7. Root 2 is like 2 to the power of a half. So this becomes like 2 to the power of 7 over 2, which is 2 cubed, so 8 root 2, times by 2 cubed, which is 8, times by cis. Now I'm going to bring these together, but just note, I will eventually simplify this component, because 21 pi on 4 is the same as 5 pi plus pi on 4, or 5 1/4 pi on 4. And we can remove 2 pi's, because that's a full cycle. So if you move back around the circle of 2 pi, it takes you back to the start. So we can remove multiples of 2 pi, giving us 1 1/4. But I'm going to choose to add these together first, using that second rule. So 21 pi on 4 plus 3 pi on 3, which is just pi, becomes 20, oh, I'm still on highlighter, becomes 25 pi on 4. And then this is all over, and on the bottom I've got 2 to the power of 4, which is 16, cis inside here, pi on 2 minus 4 pi on 6, which is 2 pi on 3. Well, I'll leave it as 4 pi on 6. Pi on 2 becomes 3 pi on 6. So I'm left with negative pi on 6. And now the 8 and that 8 and this make that a 2. That and this make that 4 pi on 2. So I'm left with 4 root 2 cis, and now we just do our subtraction. 25 pi on 4 minus negative pi on 6, and this is fun. Now they can both go to some number out of 12, so I'm going to change this guy will become 75 pi on 12, and plus this guy will become 2 pi on 12, and so I end up with 77 pi on 12. So it's 4 root 2 cis 77 pi on 12. Now I can write this down as 4 root 2 cis, how many 12s in 77? Well, that's 6. And we're left with 5 twelfths pi. I can take away multiples of 2 pi, so it gives me a final answer, 4 root 2 cis. I can take away that whole 6 pi, so just 5 pi on 12 is left. And that's probably the best answer I can come up with. So we'll leave it as that. Well, thanks for exploring DeMoivres doing with me. It doesn't have to be that tricky, but it probably looks a bit tricky based on some of these examples. Just work through the exercise and make sure that you email me any questions or come and speak to me if you need. All the best.